Today's agenda will be a brief overview of some of the Zynq UltraScale Plus products, and then the features of our AcroPack Zynq UltraScale Plus, the carrier boards that will host our AcroPack, and we'll briefly go into some of the development tools, the engineering design kit and software available. We'll talk briefly about some applications, and then we'll give you an overview of the FPGA products that we still support in the Xilinx offerings, and then we'll open it up for questions. So the Zynq UltraScale Plus MPSoC multiprocessor system on a chip. They actually have three series. They have the CG series, the EG series, and the EV series. Most of our conversation today will be focused on the CG series. We use the XCZU 3CG in our product in a 484-pin package. The CG series has a dual-core Cortex A53 application processor. With that comes a Neon media processing engine, and then it also has a dual-core Cortex R5, which is a real-time processing unit. The EG family has the same set of features, except that it uses a quad-core Cortex A53, and it adds a GPU unit based on the Mali 400 MP2. Our products are primarily going to be CG, but there is a possibility to do a pin-compatible EG with the AcroPack Zynq UltraScale. The Zynq EV family has the same features as the EG, but it adds a video codec that can do H.264 and H.265. This slide shows the APZU-30X, and we're introducing three I/O versions. We'll have a 301, a 303, and a 304. And just a couple of key points looking at the block diagram. There's two parts of the Zynq UltraScale chip. There's a processing system where the ARM processors are, and then there's the programmable logic side, the PL side, and that's where the reconfigurable logic is and the I/O are. With respect to the block diagram, you can see that we are pinning out a Ethernet that's 10, 100, and 1 gig compatible to the field I/O, a USB 2.0 port, a USB to UART, and then we also have a power switch and a reset switch, and that is common amongst all three model numbers. And then the I/O is different in that the 301 will have 28 TTL, the 303 will be a combination of 20 TTL and 3 RS-485/422 serial channels, and then the 304 will be 14 low voltage differential signaling channels. We also will have a APZU breakout panel. It's basically a printed circuit board and has the magnetics on it for the Ethernet, so you can connect up an RJ45 cable. It'll have USB 2.0 connector, and then I'll have a USB to UART comms port and the digital I/O available on this breakout panel. And we'll talk in more detail later about that. The primary boot for the processors is through a micro SD secure digital card. And you can see in the picture of the AcroPack left, we've got a socket there that the micro SD will plug into. There's also another boot option in case that you want to boot through the quad SPI flash. So you'll have the ability to load your OS either through the micro SD or the quad SPI flash. There's 2 gigabytes of low power DDR4 SRAM, DRAM on the board, and that's organized at a 512 by 32. So the processors on the CG family, as I mentioned, dual core ARM Cortex A53. This is ARM 8-like. It operates up to 1.3 gigahertz, and it is a 64-bit data and 64-bit instruction. Within that application or processing unit, there's a Neon processor, which I will talk about in a little bit. There's also the dual core ARM Cortex R5, the real-time processor. This operates up to 533 megahertz and is a 32-bit architecture with hardware floating point. The media processing engine called a Neon, it's part of the application processing unit. It's an advanced single instruction multiple data architecture, and it basically allows you to accelerate audio and video encoding and decoding and accelerate signal processing algorithms. So it's a hardware accelerator. This is an example of an FPGA logic cell, and it's identified as a 6-input lookup table, or LUT, and the logic cell. A lookup table is also commonly referred to as a function generator. And I show you this so that you can understand the ability to take a configurable logic block, and each one of these configurable logic blocks has 8 of these LUTs and 16 flip-flops. So you're able to reconfigure however you want to interconnect the logic blocks, as well as being able to reprogram them at your performance requirements. The next slide shows how you measure device capacity. So here are 3 different size FPGAs at the top: an Arctic 7 50T, an Arctic 7 200T, and a Kintex 7 325T. So below you'll see that the ZU3CG, which is our primary AcroPack Zynq UltraScale device, and how it compares. A couple of notes: the logic cell is equal to a 4-input lookup table and 1 flip-flop. This was the Xilinx came out with initially, and it changed with the introduction of the Vertex 5 family, that the logic cell became a 6-input LUT. So Xilinx came up with a ratio that a 6-input LUT was 1.6 times a 4-input LUT. So therefore, you were able to come up with how many equivalent logic cells so that you could measure sizes of the different FPGAs. So we offer a AcroPack 7A 50T version, the APA 7-501, 2, 3, and 4, and it has approximately 52,160 logic cells. Now, when you go with the Zynq UltraScale, since there is a lot more functionality, more resources available in a Zynq UltraScale, Xilinx came up with a ratio scaling factor of 2.1875. So there's approximately 70,560 6-input LUTs on this 3CG product. So when you do the math, it comes out to 154,000 logic cells. So as you can see, it's about roughly 3 times the size of a 7A 50T in terms of logic cells on this board. Processor memory is comprised of 32 kilobyte L1 caches, both instruction and data, and then it has 1 megabyte of a unified L2 cache, which is shared between the processors. So dual core or quad core will share that memory. And then there's a 32-bit interface to the 2 gigabytes of LPDDR4 main memory. The one key item to note is that working with the Zynq UltraScale, you will boot up the processor system first, and then when you configure the programmable logic, that control will be done by the processing system. All of the AcroPacks, including the Zynq UltraScale, include a PCI Express by1 interface that's running at Gen 1, which is 2.5 gigabits per second. It's compliant to PCI Express base spec revision 3.1, and there are 2 general purpose DMA controllers on the Zynq UltraScale. The I/O peripherals that we plan to take, there are 4 gigabit Ethernet controllers on the Zynq UltraScale. Due to the limitation of the I/O, we are just going to be pinning out 1 triple speed gigabit Ethernet channel. And this will use a reduced gigabit media independent interface, abbreviated RGMII. And in the picture, you can see that there is a small breakout board. That's the 5028-626. So what you have is a 68-pin cable connected to the carrier on the upper right side of that picture. This cable is 1 foot in length. It goes to the printed circuit board below, and then the Ethernet magnetics are on that board, allows you to have a copper RJ45 port, and you can see a USB 2.0 port, as well as a USB to UART COM port available. And then you'll see a couple of buttons down at the bottom of that printed circuit board. One is for power and one is for reset. And then you'll have all the digital I/O that are coming out of the Zynq UltraScale, whether it's TTL, low voltage differential, or the combination at those jumpers. You can see 4 jumpers down there. So this is a development board that we recommend customers get to start with. However, your application will dictate what you will go to production with. As I mentioned earlier, there is a secure digital interface, and this is the primary boot. It's a 16 gigabyte micro SD. So that will be your primary boot. We will include that in the shipment of the product. And that will allow you to load Petalinux and whatever other software that you are going to need. You have a secondary boot option with a flash device, which is much smaller. So one could do development using the micro SD flash card. And then once you optimize your code, you could boot from the quad flash device. We use I2C to communicate with a 2K EEPROM for the Ethernet MAC ID and for the power chip that monitors voltages and temperatures on the board and on the chip to make sure that things stay within spec. And here's an actual picture of the AcroPack Zynq UltraScale with the heat spreader included. And the size is 12.5 millimeters high, 70 millimeters long, 30 millimeters in width. And this, with the heat spreader, weighs 35.18 grams. Now, a power dissipation with approximately 80% of the resources used on there will be sub 5 watts. So carriers for the AcroPack Zynq UltraScale and our other AcroPacks. So from a PCI Express server slot based, we have basically 4 carrier cards. We have a 7012, which will support 1 AcroPack. It's a by 1 edge connector interface. It's small, it's a half height card. It also has the ability to host other AcroPack modules that use isolated DC to DC modules for power. We also have a dual AcroPack carrier called the APCE 7022. It has a by 4 edge connector interface, and it also contains the ability to host other AcroPack modules, as well as we've developed all of our carriers to be able to host mini PCI Express cards as well. And then finally, for the PCI Express servers, we have 2 quad carrier boards. One is a full-length carrier called the APCE 7040, and the other is a 3/4 length called the 7043. There's a picture on the right of the quad, and that's the full-length version. It has the ability to host analog isolated modules, as well as up to 4 AcroPacks or combination of AcroPacks in mini PCI Express cards. So other carriers for our AcroPacks and our Zynq UltraScale, we have an XMC AcroPack carrier called the XMC AP2020. That's the front I/O version. The 2021 is a rear I/O version. And then we actually have a 2022, which is a carrier that's used in our ARCS box, our ARCS 4000 box, to host 2 AcroPacks. On the 6U VPX side, we offer 2 6U VPX carriers, the VPX 4520, which has an expansion plane interface, and the VPX 4521, which is a data plane interface to the back plane. Each one of these supports up to 4 AcroPack modules and 1 XMC card that can be either a Vita 42 or Vita 61 configuration. We have them available in both front I/O, air-cooled, or rear I/O, conduction-cooled versions. Earlier this year, we introduced a new carrier called the ASICS 4041 carrier. It hosts 4 AcroPack modules and an M.2 storage and requires a Type 10 COM Express processor. We then took this carrier and we introduced an ARCS 1100, which packages this carrier in an IP65 chassis and then adds a removable 2.5-inch solid-state drive. Some other AcroPack Zynq UltraScale carriers. We support compact PCI Express serial. We have 2 versions. We have a ACPS 3310, which is a front I/O, and will host 2 AcroPack modules. And then we have the rear I/O version, which will host 2 AcroPack modules, and we also have a rear transition module to go with that, and that's the ACPS 3320. Engineering design kit and software drivers. So we are offering and will be providing what we call an APZU-EDK. And the engineering design kit is a must-buy with the first purchase. It provides example code of intellectual property blocks, the RAM, system monitors, AXI interfaces to the digital I/O. It's the code, it's what I would call known good code that you can take and import into your Vivado development environment and actually know that this code has been debugged and it works, and it's a starting point for you to then add your application and start making modifications. So this is a one-time first purchase. And we also recommend our 5028-626, which is an I/O breakout panel with a 68-pin cable. It's a male-to-male cable, 1 foot long. The one side of it plugs into the carrier front panel, and the other side plugs into the little breakout panel, giving you the Ethernet, USB, and digital I/O. And then we support our APIs for Linux, which is a free website download. We also support Windows, and we support VxWorks 7.0. Development tools for the Zynq UltraScale. They'll be Vivado 2020.1 design suite, and then Vitus, which is a unified software platform. It sits on top of Vivado, and it allows you to do your development on a variety of different Xilinx platforms, including the systems on a chip and the Versal ACAPs. So the Vitus software provides compilers, analyzers, and debuggers so that you can do your design, your software development, and code development. Linux is an embedded Linux systems development kit that targets Xilinx system on a chip designs, and this will also be available. It includes U-boot, Linux kernel, device tree, and a root file system components. And then the 5028-626 breakout board. As I mentioned, this breakout board will allow you to have access to the Ethernet port, USB 2.0, and a comms port, and the digital I/O at the jumper blocks, and then a power and reset button. Some typical applications that we believe the AcroPack Zynq UltraScale will be used for. We see that there could be protocol converters out there that you may want to go from one type of format to another, and with the processing and memory and the algorithms available, you would be able to use that in an application. Hardware in the loop, where you're trying to simulate something, is another key application for the Zynq UltraScale. Video capture and recording, interfaces like camera link and USB and Ethernet would make that very capable for that. And then video packet interrogation, if you're doing some type of application with facial recognition or license plate numbers, things like that, it would be very beneficial. Missile simulation, the ability to simulate not only a missile but other types of weapons would be a good possibility for this. And then to take a variety of different sensor data acquisition and process those, send them along, that sort of thing would be another application that we see. So Acromag is very strongly partnered with Xilinx, and we support currently the Vertex 4, the Vertex 5, Spartan 6, Kintex 7, the Arctic 7 in both a XMC form factor and in an AcroPack form factor. And then with the development, with the introduction of the new Zynq UltraScale, we'll be supporting the APZU-30X family. And then somewhere down the road in second half of 2021, we hope to have an XMC Zynq UltraScale offering. So I encourage you to check out our website to find out about all of our existing products at acromag.com. And if you have specific questions that Amar Sater, our applications engineer, can answer, there's his email and phone number. And then myself, you can reach out to me via my direct line or send me an email, and we'll be happy to answer any questions about Acromag. At this point, I'd like to turn it back over to Ryan for questions, and thank you for your attendance.
Thanks so much, Greg. I appreciate the rundown. Yeah, we will open it up for Q&A, so feel free to type that into the questions module inside of the webinar, and we'd be happy to answer any questions, and we'll look at them as they come in. A couple things I just wanted to clarify and get updates on. So when will you be shipping the APZU boards, Greg?
So our plan is to release the product before the end of the year, probably in December. And then we hope to be shipping the boards in the first quarter of 2021.
Okay. And you were talking about some of the tools at the end there, and I just wanted to make sure this was clear. So is the Breakout Board required for hardware development?
Well, the Breakout Board is not absolutely required, but it will help with time to market in that it is available. It has all the I/O, like the Ethernet, USB, and the digital I/O. It's all pinned out to this Breakout Board. A customer could make their own custom Breakout Board, but that would take a little more time and effort. But eventually, in your application, the customer will most likely have their own custom Breakout Board.
Okay. And it sounded a little bit different. Is the EDK required?
The EDK, Engineering Design Kit, it is required with the first purchase of the FPGA because it provides the code that will be imported into Vivado. So it is a one-time purchase upfront, and it has a site license so that multiple people can use it at the same site, and it is a requirement.
Okay. I just wanted to make sure that was clear. And I don't know if you mentioned it in too much detail. I just wanted to ask, what other AcroPacks do you have? What kind of families do you have to go along with this FPGA module?
So we have a variety of analog and digital I/O AcroPack modules, serial AcroPack modules, 422, 485, 232. And then we have some specialized AcroPack modules for 1553 and CAN bus. And then the other FPGA AcroPack modules that I mentioned were the APA7, the -501, 2, 3, and 4, which are based on the 50T and provide a variety of TTL, combination serial, and LVDS I/O.
Okay. How does the price point compare to this new product compared to the existing AcroPacks? Do you guys have a target in mind?
Yes. So the existing 7A-50X family is priced at around $1,040, and the new Zynq UltraScale product will be priced roughly in the $2,300 range. As I alluded to one of the earlier slides, there'll be about 3 times as many resources, logic cells on the Zynq UltraScale, and the price will be roughly about 2.1 times. So there'll be a good value proposition for moving up to a Zynq UltraScale if you can use the resources available.
Okay, that sounds good. And all of the AcroPacks you talked about are compatible with the carrier cards you described earlier.
Yes, all of our AcroPack modules will plug into any of those carriers that I described earlier in the presentation. And then we have a variety of cable solutions. We have a cable that goes from the front panel to a breakout termination block. We also have a couple different lengths of pigtail cables so that you can terminate the one end on your device under test yourself. So